With the present time, we learn something about performance of the pump. So performance of the pumps means how the pump is executing its level, whether it attained the level of expectation in terms of output, if attained or not. If attained means how will we improve better. If not attain that level, what extent we develop the pump in a certain level. So the first performance categorization is volumetric efficiency. So volumetric efficiency indicates the amount of leakage that takes place within the pump. This involves considerations such as manufacturing tolerances and fluxing of the pump casing under design pressure operating conditions. Volumetric efficiencies typically run from 80% to 90% for gear pumps, 82% to 92% for vane pumps, and 90% to 98% for piston pumps. Actually, the volumetric efficiency, it's specified as actual flow rate produced by the pump to the theoretical flow rate should produce. So this is the ratio from which we can calculate the volumetric efficiency. Then mechanical efficiency. So mechanical efficiency indicates the amount of energy losses that occur due to reason other than leakages. This includes friction in bearing and between other mating parts. It also includes energy losses due to fluid turbulence. Mechanical efficiencies typically run from 90 to 95%. The theoretical power required to operate the pump to the actual power delivered to the pump, or the power output assuming no leakage to the input power delivered to the pump. Then move on to overall efficiency. The overall efficiency considers all energy losses and is defined mathematically as follows. So overall efficiency is equal to volumetric efficiency into mechanical efficiency divided by 1000. So this is the thing. So this is the chart shown here. So the type of pump with the based on the type of pump. So what will be the changes and all things we have seen. So it specified pump type, pressure rating in terms of PSI, speed rating in terms of RPM, overall efficiency in terms of percentage, HP power LB ratio, flow capacity and cost dollars per HP. External gear pump 2000 to 3000 is the pressure range. Then speed range 1200 to 2500. Then efficiency 80 to 90%. So here the ratio is 2. So flow capacity is 1 to 150. In cost 4 to 8. Then internal gear pump 500 to 2000 pressure rating and speed rating 1200 to 2500. The efficiency is 70 to 85. Then ratio is 2. Then flow capacity 1 to 200. Here also the cost wise 4 to 8. Then vane pump. So 1000 to 2000 is the pressure rating. 1200 to 1800 is the speed rating. Then efficiency is 80 to 95%. Then ratio is 2. Then flow capacity is 1 to 80. Then as per cost 6 to 30. Then axial piston pumps 2000 to 12,000. 1000 is the pressure rating. Then speed rating is 1200 to 3000 in terms of RPM. Then overall efficiency is 90 to 98%. That's why we are preferring axial piston pumps. So ratio is 4. Then flow capacity is 1 to 200. Then cost is 6 to 50 dollars per HP. Then finally radial piston pumps. It's having pressure rating 3000 to 12,000. Then speed rating is 1200 to 1800. Then efficiency is 85 to 95. Then ratio is 3. Flow capacity is 1 to 200. Then cost 5 to $35 per HP. Then the selection of pump. Select the actuators, that is hydraulic cylinder or motor, that is appropriate based on the loads encountered. Determine the flow rate requirements. This involves the calculation of the flow rates necessary to drive the actuator to move the load through the specified distance within the given time limit. That should be ensured very much. Then select the system pressure. This ties in with the actuator size and the magnitude of the resistive force produced by the external load on the system. That should be also ensured. Determine the pump speed and select the prime mover. So prime mover is the primary source. So we execute the system. Select the pump type based on application. Select the pump type based on the application and cost wise. So if we select based on application, that is very essential. So with respect to cost, that should be considered. If we application based acceptable, the level of output and efficiency are all okay. If cost too much means it very difficult to access. So that should be specified in a right way. Select the reservoir and associated plumbing, including piping, valving, hydraulic cylinders and motors and other miscellaneous components. So getting a thing is not a matter. So we have to collect and utilize the ancillary concepts in a right way. So that should be available in the market. It's available in the market, but the cost wise it should be very less. If any problem means we should be able to replace in a short span of time. That should be we have to analyze. So if in first term we have to utilize plenty of money. So if any replacement, any changes in their part means we have to adapt with that changes. Then only we can survive. Otherwise, if any fault or if we need to change any changes means it is very difficult to proceed further. That should be finalized. Consider factors such as noise level, HP losses, water wear. So this should be considered as much. Then finally calculate the overall cost. So what will be the overall cost? So independently it's accumulated and finally we get a single terms of value. In terms of single value. So that is the overall cost. That should be in the span of minimization. We have to consider in such kind of way. So this is the selection of pump. The criterion should be followed when we are selecting the pump. So first thing is cost as well as the application and then the output. So if these things fulfill means we can do any kind of alteration in the pump. It should be specified.